Hey guys, so in today's lecture, we are going to discuss an example relating to the theory which we have studied in the last lecture. So, this is an example which was asked in GTU exam. So, this was asked in 2017. So, in this example, we need to find the present worth of a fuel over 20 years. So, for a non solar process using fuel only, the present worth of the fuel cost over 20 years, if the first year cost is 1,25,500, the market discount rate is 8% and inflation rate is 10%. So n is 20 years, then E1, that is cost, that is first year cost, is 1 lakh, sorry, 1,25,500, and the market discount rate, so discount rate D is 0.08, and inflation is 0.1. So we will use the present worth factor formula, that is, so that is PW is equal to A1 upon D minus I into 1 minus 1 plus I divided by 1 plus D raised to N. So we'll put the terms in this equation, so we will get an answer. So what is E1? E1 is 1,25,500 divided by D minus I, that is 0.08 minus 0.1 into the bracket 1 minus 1 plus 0.1 divided by 1 plus 0.08 raised to N is 20. So after solving this, we'll get an answer. That is present worth is 2782,335. Tick. So this is the present worth over 20 years. So if you see, so this fraction is around E1 into 22.17. So around 20 years, the fraction is 22.17. So it is not 20, it is greater than 20. So the worth of your present money is more worthy than in future. So that is the conclusion, the present worth. So now I'll see another example. So this is another example. This was also asked in GTU. So what is in this example? We'll see one by one. So the cost of a PV street light system. So there is a street light system, that is photovoltaic PV street light system, which is 45,000 rupees. That is a 45,000 rupees. The cost of conventional energy saved. The cost of conventional energy saved due to its installation is rupees 4,500. So what does it is saying? 4500 in the first year. So instead of conventional energy street light, we are using photovoltaic, that is solar street light. So on the first year it is saving around 4500 rupees, and this cost inflates at the rate of 6% per year. So it will inflate at the rate of 6% per year. Now what we are interested in, so we need to find, that is calculate the payback period, that when my this cost 45,000 will be returned to me. So we need to calculate the payback period with and without discounting. With discounting, without discounting. So what is the discount of the system, and take the discount rate as 10%. So 10% discount rate we need to account. So we will see. So before solving this sum, we will understand what is payback period. So as we have not discussed about payback period, so what is payback period? So payback period is the time needed for a cumulative savings on a fuel or electricity in the case of a standalone system, or income derived from power fed to the grid in case of an add-on system, equal to the initial investment. What does it mean? So as the name suggests, is payback. So if you're paying something for savings, for getting savings in the future, so when that savings will be equal to the initial investment which you have invested, so that is payback period. So the savings in the account of a fuel of electricity in the first year is, suppose savings is around CF. Suppose we are saying savings is for the first year, that is E1, that is CF into FE. So CF is the cost of fuel into fraction, sorry, into F is fraction of the load that is saved, and E is the total load. So this is the savings. So this we can say it as E1, or just CF CF into FE for a standalone system. So let us denote this quantity by the symbol as B. So we are taking this quantity as B. So the income derived from the sale of the electricity fed into the grid in the first also be denoted by the same symbol B. Thus the savings or the income for both the system without discounting will be, so what will be the savings for the system? So this is the savings for the first year. So we need to calculate savings for the jth year. Savings for jth year, so will be equal to, we'll use the compound interest formula, it is 1 plus if raised to j minus 1 into b. It is compound interest formula. So if the payback period is NP, so NP is the payback period, so it will follow that at NP year, at the NP year, the initial cost will be equal to the savings. So this savings will be equal to the initial cost. So that is the cost. That is the cost of the equipment. So cost of the equipment should be equal to this. So cost of the equipment should be equal to sigma 1 to NP into 1 plus if raised to j minus 1 into b. So, so if we solve this sigma, so we will get b is a constant, so it will come out, so into bracket 1 plus if raised to np minus 1 upon if. So this is the formula for the cost of the system, which will be returned after n period. Is np is here payback period in number of years. So this we have to find np payback period. So we will make np as a subject. So we will get np is equal to log of, it is ln in if into c, it is if into c, we are multiplying if into c, divided by b, it is divided by b, and this minus 1 will come this side, so plus 1 into, we are taking log on both the sides, so we will get ln into 1 plus if. So this is the formula for payback period. So this formula we are going to use in the equation, but there is one more thing, that if discounting is given, so what we'll do at that time. So if discounting is given, then our formula will change. So what will be the formula? So c will be equal to sigma 1 to np, j running from 1 to np, 1 plus if raised to j minus 1 divided by 1 plus d raised to j into b. So here we have added one discount term also. So now the formula will be equal to np will be equal to ln into 1 minus c into d minus if upon b divided by ln into 1 plus if divided by 1 plus d. So for this two equation, there is without discount and with discount. So this both equations we have to use in the above example. So we will go with for the first, that is without discount. So we'll get back to this this example. So here the c is 45,000. So we'll plot the data first. So c is 45,000. Then the first year b is 4,500. Then I is 6% and d is 0.1%. So we'll write this. So here I have written the data. Cost of the equipment 45,000. The first year savings 4,500. The interest or inflation, that is 0.06%. Discount 0.1%, and payback period. So we will find directly the NP without discount. Formula is ln if into c upon b plus 1 divided by ln into 1 plus if. So this formula we will use. So here ln into I is 0.06 into C is 45,000 divided by B is 4,500 and plus 1, so it will be 0 45 we are left with 10. So this will be divided by our ln into 1 plus 0.06, so this will be equal to ln into 0.6 plus 1, that is 1.6 divided by ln 1.06. So this will be 1.6 divided by 1.06. So the answer will be equal to 8.066. So around 8 years it will take without discount. And now if we consider the discount, then what will the formula? So if we consider the discount, then our formula will be, so now we will calculate with discounting. So if discounting is given on the fuel, then the payback period will be increased. That if the conventional fuel is getting discounted, that is petrol, diesel is getting discounted, then our retain our initial cost will take more time. So discounting is less beneficial to the adoption of the renewable sources. So let's see the formula for with discounting, that is ln, there is 1 minus C into D minus IF divided by B divided by ln 1 plus IF divided by 1 plus B. So we'll put the values, that is ln into 1 minus cost of the equipment, that is 45,000, let's write 45k, into D is 0.1, 10% discount minus 0.06 is the interest, divided by, sorry, so that is divided by B. B is 4,000, 4.5k, 4,500. So this will be into 10, then divided by ln into 1 plus that is 0.06 divided by 1 plus 0.1, so which will be equal to ln into 1 minus, so now 0.1 minus 0.06 will be equal to 10 minus 6, it is 0. So this will be 10 into 0.04, that will be equal to 0.4. So 1 minus 0.4 will be equal to 0.6. So this will be equal to ln into 0.6, sorry, this will be equal to ln into 0.6 divided by ln into 1.06 divided by 1.01. Oh, sorry, it is 1.1, not 1.01. It is 1.1. So this NP will come around 13.79 years, so nearly equal to 14 years. So as you can see, if we are not getting discount on the fuel, then it will be in 8 years if it is discounted. So it has been increased to around 5 to 6 years. 5 to 6 years has been increased. This is very high payback period, and generally, so this payback period is less preferred. So this is the main reason why people do not prefer conventional fuels. Sorry, does not prefer alternative fuels and stick to the conventional fuels. So if this payback period is reduced, then and then the acceptance of solar photovoltaic will be accepted. So thank you very much. So I hope you understood these equations and where it is being used. So thank you.